Math 100, Lesson 10.3, multiply and simplify radical expressions. So if we have two radicals that we want to multiply, and they have the same in value here, we are taking the same root, then we're able to multiply inside. So if I had the square root of 15 times the square root of 11, that would be the square root of 55. Or if I had the cube root of 6 times the cube root of 10, I could say that is the cube root of 60. So I would not be able to multiply a square root times a cube root using this rule. I could do, if I have the square root of x plus 4 times the square root of x minus 4, that would give me the square root of x squared minus 16. When I multiply those two together, x plus 4 times x minus 4, that is the difference of squares. The seventh root of 2x times the seventh root of 6x cubed would be the seventh root of, multiply the 2 and the 6, we get 12. Multiply the x times the x cubed, and I would add the exponents. So we are able to multiply through the radical as long as the index is the same, the root is the same. So we're going to use that idea to do some simplifying. If I have the square root of 75, I can think of this as going backwards from what we just did. I know that 75 is 25 times 3. So that would be the square root of 25 times the square root of 3. Well, I know the square root of 25 is 5. I cannot do the square root of 3. So this would be my answer. 5 on the square root of 3 is how we say that, or 5 times the square root of 3. Not looking for a decimal answer. Right, if I have the cube root of 40, then what I want to do is find some number that I can take the cube root of, like 8. So this would be the cube root of 8 times the cube root of 5. I can do the cube root of 8. It is 2. I cannot do the cube root of 5. So my answer would be 2 on the cube root of 5. All right, if I have the fourth root of 32, then I want to look for two numbers that multiply to give me 32, but one of them that has that I can take the fourth root of. So 16 times 2. Because I can do the fourth root of 16, and that's what I want to do. The fourth root of 16 is 2. I cannot do the fourth root of 2. So my answer here would be 2 on the fourth root of 2. All right, let's put some variables in there. Still simplifying. So the square root of 200x squared y. I want to do the same thing. I want to break it down into two things that I can take the square root of one of them, and then maybe I can't take the square root of the other. So I can take the square root of 100. I can take the square root of x squared. 100 times 2 gives me 200, and then I need that y. So the first two that I listed here, I can take the square root of 100x squared. I cannot take the square root of 2y. So that's why I choose to separate them. So the square root of 100x squared would be 10x on the square root of 2y. And remember, we learned earlier when we were doing radicals that if we take an even root and we get an odd exponent, we need absolute value. Unless the directions specify that all of our solutions are positive. Okay, let's try another. Let's say I give it to you in the form of a function. All of that is under my radical. And I want you to simplify. My directions are still simplify. Well, I can't simplify that radical until I factor it. Okay, you can't separate it with the minus or the plus. So I need to factor. I'm going to factor out a 3. I get x squared minus 4x plus 4. Now I'm going to factor that trinomial. Right, two things that multiply to give me 4, but add to give me negative 4. I'm only looking in the parentheses. So that would be negative 2. I like faux fractions. My a value with x over one of them. My a value with x over the other. So I have x minus 2 times x minus 2. Now a better way to write that is x minus 2 squared. Because now I can take the square root of that x minus 2 squared. And I get the absolute value of x minus 2, but that 3 has to stay inside that radical. All right, let's go to another one that's just variables, not function notation. We're still simplifying. So I like to think about it as I'm going to break it up into things, two separate radicals. The first radical is going to be the one I can simplify. So here's what you need to look for. All right, so when I'm taking the square root of x to the 9th, all right, the square root of x to the 9th. 9 divided by 2 is not a whole number. But I know 8 divided by 2 is a whole number. So that's what I'm going to do. I'm going to use x to the 8th. Now, I can't just change that from x to the 9th. So x to the 8th is going to go under my first radical times x in the second radical, which gives me x to the 9th. I'm going to do the same thing with my 11. 11 divided by 2 is not a whole number, but 10 divided by 2 is. So I'm going to use y to the 10th. Can't just change it to y to the 10th. I have to have y to the 11th. So I put that other y in the other radical. And then for my z's, I'm going to use z squared here and then times z over there. Now, everything I put in that first radical, I can simplify. The square root of x to the 8th is x to the 4th. Y to the 10th would be y to the 5th. And z squared would be z. And then I still have the square root of x, y, z. Now if I'm paying attention to where do I need absolute value, I'm going to need absolute value. This time won't matter because I still have variables under the radical. So I actually won't need them on this one. All right, let's do the cube root of 40 x to the 10th, y to the 14th. All right. So I want to break this up into two radicals. One of them this first radical, I want to be able to simplify. So I'm looking for a number that goes into 40 that I can take the cube root of. That's 8. Well, you can't just change 40 to 8. So I put 8 times 5 goes in the other radical. 8 times 5 is 40. So if I pay attention to my variables, I would have to have x to the 9th here. And then I'll have an x over here. It's got to be x to the 10th. And then I would have y to the 12th times y squared. Now I chose x to the 9th because 9 divided by 3 is a whole number. I chose y to the 12th because 12 divided by 3 is a whole number. Now this first radical I can simplify. The cube root of 8 is 2. The cube root of x to the 9th is x cubed. And the cube root of y to the 12th is y to the 4th. And then all of this stays inside this radical. Now, a big mistake that I see people make when they type their answers into My Math Lab on this particular homework assignment is they forget to put that number right there. The only time you don't see a number there is if it's the square root. We don't put the 2 there if it's the square root. But if it's the cube root, the 4th, the 5th, any other root, we have to put that number. Otherwise, the computer sees it as a square root, and it'll count your answer wrong. Okay, let's try something a little different now. This time, instead of just simplifying, we are going to multiply and then simplify. Okay, we're going to multiply and then simplify. Now here's why. You can't simplify the square root of 6 or the square root of 2. So I'm going to go ahead and multiply and get the square root of 12. Now, the square root of 12 can simplify because the square root of 12, I can change that to 4 times 3. I can take the square root of 4, it is 2, so it comes out, and the square root of 3 stays there. So my answer will be 2 on the square root of 3. All right, 10 on the cube root of 16 times 5 on the cube root of 2. Okay, now my directions here tell me to multiply first. So that's what I'm going to do. I'm going to multiply first. So 10 times 5 gives me 50. I am doing the cube root. They're both cube roots. That's why I can multiply inside. 16 times 2 is 32. Now that can be simplified. Okay, it told me to multiply. So that would be my first answer. And now simplify. So the cube root of 32, I can break that up into 8 times 4. Right? So if you need to see the cube root of 8 times the cube root of 4, if you need to see it written separately. The cube root of 8 is 2. And then we've still got this cube root of 4. So when I take the cube root of 8, I get the answer 2. I have to multiply it by the 50 that's sitting out there. So I get 100 on the cube root of 4. That would be my answer for that one. These radicals are just going to take some practice. The better you are with your multiplication, the easier these are. All right, let's try the 4th root of 4x squared y times the 4th root of 8x to the 6th y cubed. Our directions are still multiply and then simplify. So I will multiply. They're both 4th roots, so I can multiply. So 4 times 8 gives me 32. X squared and x to the 6th will give me x to the 8th. And y times y cubed would give me y to the 4th. All right. I cannot take the 4th root of 32. All right, so I'm going to have to break this up into a 4th root times a 4th root. I can take the 4th root of 16. 16 times 2 would give me 32. Now the good news here is I can take the 4th root of y to the 8th, x to the 8th and y to the 4th. Remember, we check that by saying 8 divided by 4 and 4 divided by 4. So this first radical can be simplified. The 4th root of 16 is 2. The 4th root of x to the 8th is x squared. And the 4th root of y to the 4th is y. The 4th root of 2. Now, if our directions did not say that we were assuming all answers to be positive, we would need an absolute value this time around the y. There's not a y left in the radical. We took an even root, we got an odd exponent. All right, so these are just going to take some practice working with your radical expressions. So let me know if you've got any questions.